Okay. Well, welcome everybody. Thank you all for coming in here. Thank you for joining, and thanks to Friends of the Forest Preserves for organizing this session, Take Action Against Climate Change in the Forest Preserves. I'm gonna start out by introducing Derek Ziomber, the Northside Field Organizer for Friends of the Forest Preserves, who will read a land acknowledgement for us all.
Let me quickly share my screen so you can read along if you're interested. Just give me a second. Okay, Friends of the Forest Preserves acknowledges that the forest preserves in Cook County are located on the ancestral homelands of the Council of Three Fires, a longstanding Anishinaabe alliance of the Ojibwe, Ottawa, and Potawatomi North American Native tribes. These lands have also been home and a place of trade for many other tribes, including the Fox, Ho-Chunk, Menominee, Meskwaki, Miami, and Sauk people. For centuries, these Native Americans cared for and protected these lands until ownership was largely stolen from them by US colonizers. Today, we employ certain land management techniques that follow indigenous practices. However, our forest preserves and our communities would greatly benefit from more intentional application of indigenous knowledge in how we manage and honor our protected areas. Chicagoland is home to one of the largest and most diverse urban Native American communities in the United States. Community members celebrate, practice, and adapt their heritage and traditions within our modern urban environment. It is our responsibility to find common cause with community members and support their engagement with the forest preserve. If you want to learn more about our commitment to indigenous rights and the land, you can look it up on our website at fotfp.org. I'll hand it back to Pascal.
Thanks, Derek. Give me a second to introduce myself. My name is Pascal Sabino. I'm a reporter for Block Club Chicago. I cover the West Side, particularly the neighborhoods of North Lawndale, Austin, and Garfield Park. Block Club is a neighborhood newsroom. We're a nonprofit, and so we really focus on a lot of what's going on in neighborhoods across Chicago. And while my reporting tends to focus on just neighborhoods on the West Side, an issue that frequently comes up for those neighborhoods, since it's a mostly Black, it's a Black population, a lot of the issues there kind of stem from climate change, because climate change it's an issue that affects everybody. It affects things like our food systems, food access, health inequalities. Goodness, do you all remember last year or last winter in February when there was a blizzard that lasted pretty much the whole month of February, and those are things that we kind of have to accept as our new normal because of climate change. And so tonight we're going to be learning about some of the things that people can do to fight climate change, and the important role that forest preserves play in helping us to kind of be more resilient when we're thinking about climate change, as well as the effects that climate change can have on our community. So I will pass it off to Derek to tell us a little bit more about climate change.
Great, thank you, Pascal. So yeah, I'll just start with the presentation. But before I do that, we'll do an intro and I'll introduce myself a little bit more and what we'll talk about in this presentation. So my name is Derek Ziomber. I'm the North Branch Field Organizer with Friends of the Forest Preserves. I mainly work on the North Branch of the Chicago River on the west side of the city of Chicago and in the north suburbs. I help to coordinate volunteer work at a few preserves, and I work very closely with a group of volunteers called the North Branch Restoration Project. I grew up on the northwest side of the city and loved playing in the forest preserves, found it to be just a safe haven and a place to explore, and just always enjoyed it. So what I'll cover in this presentation, I'll talk a little bit about Friends of the Forest Preserves and the forest preserves in general, just a short intro to that. I'm sure a lot of you already know about those two organizations. Then we'll talk about the current state of Earth's climate, natural causes of global climate change, We'll talk about modern climate change, the greenhouse gases and carbon dioxide specifically, the effects of climate change, and then we'll talk about ecological restoration and how it can help mitigate climate change and how it interacts with our changing climate. Then we'll close the presentation and go on to the panel discussion. So, friends, our mission is that we unite people to protect, promote, and care for the forest preserves in Cook County. This is a great picture that demonstrates that. Here you can see a whole bunch of people. Oh, sorry. We have volunteers, we have Friends of the Forest Preserve staff, we have Forest Preserve staff, students, just a very large group of people, and that's really what we do. We work to get people together to care about the forest preserves and in whatever way we can. We have summer programs for high school students. We have year-round employment opportunities for adults. We work closely with volunteers. We advocate on behalf of the forest preserves. So we do quite a bit, whatever we can to help the forest preserve. The forest preserves of Cook County, this is what we're specifically talking about when we say that. This area is Cook County. All the green are the forest preserves. That's nearly 70,000 acres total, and that's actually about 11% of the county, which is kind of hard to believe in such an urbanized area. Comparing the size of forest preserves of Cook County to Indiana Dunes, this red circle is the Palos region of Cook County, and that's about 15,000 acres itself, which is comparable in size to the Indiana Dunes. So we're a large forest preserve. We're also one of the oldest in the country. Forest Preserves of Cook County is older than the National Park Service, and a lot of people think that the Forest Preserves of Cook County should be a national park themselves. Also, for reference, this is where I work, on the North Branch of the Chicago River. Some disclaimers to get out of the way. I'm not a climate scientist. Nobody on our panel is specifically a climate scientist, but we do have knowledgeable people who can speak to different aspects of climate, and some very people who are very interested in and sort of perhaps amateur climate scientists, so to speak. During this webinar, we are not going to debate climate change. The science is settled. We are causing this. So anybody who has questions along the lines of debating climate change, they're most likely going to be ignored. So please just hold on to them. But now we'll get into the current state of Earth's climate. Here is the Earth's temperature, global average temperature over the last 140 years. The important thing to note is this red line that's showing a general upward trend since about 1880 or so. This graph on the vertical axis shows temperature anomaly, which is basically means that they took the average temperatures over the course of, in this case, 1951 to 1980, and then compared all the other years to those average temperatures. And really what we see is a stark upward trend. And this has been going on ever since the Industrial Revolution, starting in about 1800. Now you might notice the black line, that's the yearly averages. The red line is kind of a smoothing. Those ups and downs might make somebody think, well, what does that mean? Is that weather? Is that, does that mean that, we don't actually know that what's happening with climate? So climate is obviously going to change from year to year, and temperature even more specifically changes across the planet from day to day at any given point on the globe. Weather is just a short-term snapshot of the temperature and atmospheric conditions, whereas climate is weather averaged for a location over a very long period of time. So when we're talking about the Earth's climate, we're talking about weather averaged over the entire globe, as best as we can, and over, the periods of years or millennia, or, just much longer than your day-to-day weather. So basically, the whole point of this is that unseasonably cold weather can occur during any period of time over any part of the globe, and we can still have global average temperatures rising. And even if we have one year that's cooler than the last year, it doesn't necessarily indicate that the global climate is not warming. But let's go further back. So 140 years is not very long. 2,000 years, though, we see a very similar story. We see these are 11 different models of climate reconstructions. All these different colors are a different different view of climate throughout the world. And what we see is that climate currently at about 1800, this black line, it just starts shooting way up. And for comparison, the medieval warm period and the Little Ice Age were periods of time when Europe in particular was either warmer or cooler than it was in the most recent history. And these are really small changes. And also you can see all these models show that, you know, it wasn't necessarily a worldwide phenomenon, but it was a big enough deal that it was historically significant. So we have the medieval warm period, the Little Ice Age over here, and we are currently way warmer than any period of time during the medieval warm period. So these small changes in temperature have historically had very big impacts on humanity. And if we go even further back, 420,000 years, we see that climate has changed quite a bit. There have been times that it's been significantly warmer, such as at the tops of these peaks, and significantly cooler, such as at the bottom of these troughs. At the tops of these peaks, we have what are called interglacial periods, which are warm periods of Earth's history. We are currently in an interglacial period, but most of the last 400,000 years or so have been glacial periods. So overall, we've been in a much colder, the Earth has been much colder of a climate, and based on these patterns, we actually kind of should be expecting our climate to be cooling and that we should be going towards an ice age. But in fact, we are not. We are going higher. And these records are based on ice cores from the Antarctic. And what they do is they look at oxygen isotopes, and there's a way to correlate the ratio of oxygen isotopes to the temperature. It's not a perfect record, but it's pretty good, and it fits what we generally know from other lines of evidence about climate. So climate has been much cooler, it's been much warmer, but right now we're in an unprecedented uptrend for temperature. And if that's happened naturally throughout Earth's history, what has caused those changes, and how is current climate change different? So we're gonna talk about volcanic eruptions, solar activity, and the Earth's orbital cycles, how that affects climate. Here we have another map of another graph of the last 2,000 years, and here we have a few different volcanic eruptions noted on the map, as well as this thing called the Maunder minimum, which was a period of time when sunspots were at minimum. I'll get into a little bit more about that in the coming slides, but you see these volcanic eruptions, they tend to coincide with low points in temperature. So here we have a trough. Here we have a trough right around the same time as some of these eruptions. Not all of them necessarily. Climate can't be entirely explained by volcanic eruptions. But how would volcanic eruptions cause a decrease in the Earth's temperature? Well, volcanic eruptions, they eject large amounts of ash high up into the atmosphere, and that ash can stay there for months or years. These ash particles, they generally are lighter in color, and a whitish or a grayish color, much lighter than the Earth's surface or the oceans. So they reflect sunlight back into the atmosphere. When we have very large eruptions, the Earth's climate can cool down for quite a few years afterwards. Here's an example of a huge column of ash that got ejected high up into the atmosphere, Mount Pinatubo in the Philippines in 1991. And temperature versus solar activity. So I mentioned solar activity and the Maunder minimum. Solar activity includes things like sunspots, solar flares, coronal mass ejections. The sun is doing all sorts of weird things that you can't tell unless you're looking at it through a telescope or very special telescopes. And what we see actually currently is that solar activity is decreasing since about the 1950s, whereas over this whole time period from the 1880s onward, we're seeing that temperature is generally rising. So if sunspot activity and other solar activity is decreasing currently, we would, and if we thought that that was causing the, our current climate change, then we would expect temperatures to be decreasing as well. But they're not. So it looks like solar activity is not causing this. Solar activity is actually has a very small effect on climate. There's only a 0.1% difference between the highest solar output and the lowest solar output. So it's really not going to impact climate all that much. And volcanic ash, even though volcanoes, they actually will release a lot of carbon dioxide, but it's actually a very small proportion compared to what we're putting into the atmosphere. So overall, what we see is that volcanoes and solar activity have not impacted climate very much. That's what this blue line is showing. That's the amount of rise or fall in climate that we expect to see from the amount of solar activity and also volcanic eruptions. So the volcanic eruptions cool the earth, increased solar activity will warm it, but we're seeing almost zero change from these two things. Whereas these lines, the human-induced line, that's going to be this darkest red line. That's how much impact humans are having on climate. Whereas the lighter orange line, or I should say the change in temperature overall, that's this red color. So when you combine human causes and these two natural causes, it adds up to what we're currently seeing. So basically, humans are causing it. It's not volcanoes, it's not solar activity. Another thing that impacts the Earth's climate is Milankovitch cycles and the Earth's orbit. The Earth's orbit, I'm not going to get into too much detail about that. Graphs showing Milankovitch cycles and the Earth's orbit are really complicated, and it's not entirely clear how exactly they fit into Earth's climate. But we do know that they obviously have some effect because the cycles of the Earth's orbit change over time. So at some points, the Earth is closer to the sun. At some points, it's farther. At some points, the North Pole is tilted more towards the sun. At some points, it's farther. This all changes the amount of radiation that the Earth receives from the sun. Very complicated, but what scientists have found is that these Milankovitch cycles and the Earth's orbit are not explaining our current trend. Now, those Milankovitch cycles do seem to have possibly been explaining past glacial periods. So that graph showing 400,000 years of Earth's temperature, that might be Milankovitch cycles. But what we're seeing now, there's no strong indication that it's caused by the Earth's climate, by the Earth's orbit. So volcanoes, solar activity, and orbital cycles, they're not explaining it. So what is? We'll take another look at 400,000 years of Earth's temperature, but add on also carbon dioxide in green. So the blue is temperature, green is carbon dioxide levels, and the red is volcanic ash. This again is from ice core data from the Antarctic, and you can look at the air bubbles trapped in the ice and the amount of dust particles trapped in the ice. What we see is that dust does not strongly correspond to the overall patterns that we see, but carbon dioxide is very strongly related to climate. And this graph in and of itself doesn't necessarily prove that carbon dioxide is causing the increase in temperatures, but we're going to go into more detail on why scientists are pretty certain that rises in carbon dioxide levels will lead to an increase in temperature. Similarly, for falling carbon dioxide, we see falling temperatures. So why are they so closely linked? It has to do with the greenhouse effect. So when the Earth absorbs sunlight, it warms up and it re-emits infrared radiation, a different type of light. Visible light comes in, infrared light comes out of the Earth. And greenhouse gases in the atmosphere, they actually will absorb the infrared radiation. And when they do that, they either start to vibrate or they will gain velocity. But when they do that, they will either transfer that energy into other molecules, like through collisions, or they'll re-emit infrared radiation. Now, we can feel infrared radiation as heat. So you look at a burning hot fire, some of that is light, visible light, but some of it is infrared radiation. And we also feel the vibrations of molecules as heat. So basically, heat is infrared radiation or it's molecules smacking you in the face. But any way you put it, the sunlight heats the earth, and the earth emits infrared radiation, and the greenhouse gases such as carbon dioxide then intercept that infrared radiation, prevent it from going back out into space, and can re-radiate some of it back down towards us. So it's trapping the sun's heat. And what sets CO2 apart from other greenhouse gases? So water vapor is a greenhouse gas. It's super abundant in the atmosphere, but humans, we're not directly causing as much change in the amount of water vapor. We do emit large amounts of other greenhouse gases. So ozone, nitrous oxide, carbon dioxide, methane. These are all gases that humans are emitting into the atmosphere. And other types of greenhouse gases are not necessarily as big of an issue because they either do not stay in the atmosphere as long or they're less potent. So for instance, methane is 28 times more potent than CO2, but it only stays in the atmosphere for about 12 years or so. And nitrous oxide is 265 times more potent than carbon dioxide. And it can stay in the atmosphere for quite a long time, but it's in much smaller concentrations in the atmosphere, so it's not as much of an issue. Whereas carbon dioxide, some of the carbon dioxide that we put into the atmosphere will remain there for thousands of years, if not hundreds. So all these other molecules, they have a relatively short lifespan, whereas carbon dioxide stays in the atmosphere for a long time. And that's because of the carbon cycle. Carbon is moving through all these different parts of the planet. Plants and the ocean and soils and the atmosphere and living creatures, those are all different sinks that hold on to carbon. And at some point in the lifetime of a carbon molecule, it is going to become carbon dioxide. One way that carbon dioxide can be absorbed and sort of removed from the atmosphere is by dissolving into the ocean. But this is overall a slower process, and it doesn't totally remove the CO2 from circulation. So the atmosphere and the ocean, they're in sort of an equilibrium, and sometimes carbon dioxide is moving from the atmosphere to the ocean. Sometimes it's moving from the ocean to the atmosphere. So it's really just trading back and forth. Similarly, for living organisms, they take in carbon dioxide and they use that, at least plants use that to create sugars and their body parts. But when they die, that gets released back into the atmosphere, into the soil. So the only way that we actually see carbon getting removed from this cycle is when it gets buried deep into sediments. So either as rock, so some rocks are actually contain carbon, or as fossil fuels. So dead plant material or living matter, it gets buried deep in the Earth's surface where it can no longer be converted to carbon dioxide, and then it changes into different forms that are more stable. But this is very, very slow. Very small amounts of all our organic compounds that make it out to the ocean are going to get buried and turned into sediments and taken out of this whole process. So humans, we've disrupted the carbon cycle. When we burn fossil fuels, we're releasing carbon dioxide that took millions of years to accumulate. And unfortunately, our carbon cycle cannot keep up with the amount of CO2 that humans are releasing. So CO2 just continues to accumulate, and as it accumulates, that leads to an increasingly warm climate. Okay, so now we got through most of the graphs. That was going to be a slightly harder part of this presentation. Now we're gonna continue on some of the doom and gloom stuff, but we'll get to more of the uplifting things and actions that people can take. But before we do that, we're going to talk about the effects of global climate change. As I've been mostly focusing on temperature, but climate is way more than temperature. Importantly, increases in temperature lead to more evaporation and more rain, more snow even, and it increases the ocean's temperature. And all of these different processes affect the way that the Earth's atmosphere and the ocean's climate circulate. And this can affect precipitation patterns as well as temperature patterns. Here's a really cool example of the Gulf Stream and its associated ocean currents in the Atlantic Ocean. Europe is actually much of Europe is further north than we are in Chicago, but we have a cooler climate than many parts of Europe that are further north. And that's because of the Gulf Stream and North Atlantic drift. So ocean currents, warm ocean waters are drifting towards Europe and keeping it a little bit warmer. And we see similar effects on the east coast of the United States and even in parts of Canada. But that's mainly because of warm ocean currents. It's not necessarily because of warm air currents. So if that gets disrupted, you could have Europe becoming much colder, or you could have all sorts of different repercussions. Now everybody knows sea level rise and melting of glaciers. Those are the classic two things pointed out for climate change. Sea levels have risen by 8 to 9 inches since the end part of the more beginning part of the Industrial Revolution. And that's partly because glaciers are melting, but also because water expands when it gets warmer. And this obviously harms coastal settlement. Polar ice caps are melting, and the rates have doubled over the time period of the last 20 years or so. And that has obvious repercussions for wildlife and water availability and all sorts of different aspects of the Earth's environment. Extreme precipitation events are also going to increase with climate change. So while we aren't seeing more hurricanes, we are seeing stronger hurricanes, and they're affecting areas further north than they used to. We're also seeing that heavy rainfall and what's called the Midwestern water hose, those types of things have doubled over the course of our modern climate change. And the Midwestern water hose, that's where basically atmospheric conditions allow moist, warm air to bypass most of the rest of the climate in the Midwest and shoot directly towards Illinois and Iowa and Wisconsin and Nebraska. So we're getting these heavy rainfall events that are becoming more frequent. And overall, our climate forecast for the Midwest suggests that cycles of drought and extreme rain are going to become more common. We're going to have less snow overall, but we're going to have more rain. But that rainfall is going to happen more in the spring and the fall, less in the summer. And this is obviously going to cause flooding. In the Midwest, we don't have to worry so much about storm surge or coastal flooding, and sea level rise definitely plays into that in those coastal areas. We do have to worry about Lake Michigan a little bit. That affects us in the Midwest, but it's not going to be as big of an impact as what you see on the coast of the oceans. But in any case, we're going to see, because we have more precipitation, we're going to have more flooding. And also because we have more drought, when the dry weather is going to dry out the soil, and it's going to make water less likely to seep into the ground and more likely to run off into sewers and streams and also your basements. Here's an example of some flooding in Nebraska from 2019. This is what the Missouri River normally looks like in this stretch, and this is what it looked like on the right during a major flooding event in 2019. You can see it's devastating agricultural areas and also human settlements, at least the edges of these human settlements. So this is something that we are already seeing in the Midwest. Food and water insecurity are also going to be issues with climate change. Food production is likely to decrease, and the availability of water is likely to decrease throughout much of the world. Not everywhere. Some areas are going to have climate that's more conducive to growing crops, and some areas are going to be wetter. But the issue is that there are going to be places that are used to having very productive land, and that land is no longer going to be nearly as productive. And the decrease in water availability is also going to impact farming as well as availability of drinking water. And because of this, we're going to see erosion of topsoil and because of climate change. And also agricultural pests and diseases are going to spread, as well as disruption of pollinators. We're not going to have the effective bees and wasps and birds and all those other things that pollinate plants. They're not going to be nearly as effective as climate change. So we're going to have less pollination of our crops. Human disease, we're going to see an increase in human disease, or at least spreading of human diseases. We're already seeing this. Mosquitoes are a big factor for this. So malaria and dengue fever, Zika, all these different mosquito-borne diseases, they're going to increase in areas that get warmer. So we're going to, in Illinois, we're going to have temperatures that are better suited for these types of diseases. Also, Lyme disease, ticks, tick-borne illness. Here at the top is 1996 Lyme disease cases, mainly centered in areas of the upper Midwest and the Northeast. In 2011, they have spread, and they're mostly spreading northward. They're spreading a little bit towards the south, but the spread is mainly to the north. And likely by the end of the century, areas that are currently tundra or boreal forest, where it's too cold for Lyme disease and the ticks that carry Lyme disease, it's going to become warm enough in those areas of Canada that they're going to have Lyme disease in central Canada. Wildfire is also going to increase. This is already happening, and it's not just because of climate change, it's also because of land management practices that have been in effect for hundreds of years across North America, Europe, Australia. And this has been especially impactful in Australia and the Western US. But we're going to see increases in fire weather as well in the Midwest. So wildfires would have been common in the Midwest 200 years ago. And this would have burned up the accumulated wood and debris that is a hazard for causing wildfire. These materials are now building up because we've been putting out wildfire. And as climate becomes warmer and drier, these combustible materials are going to become increasingly hazardous. All these things that I've mentioned, they relate to climate justice. So unfortunately, the impacts of climate change will disproportionately affect low-income communities and minority communities. So all those issues of water scarcity and food scarcity, food prices are going to increase, and that's going to affect areas of the Midwest. People who are low income or in minority communities, they have a higher likelihood of living in disaster prone areas. So they're going to incur the burden more so of the cost of storms and floods and fire damage. It's going to be much costlier for those communities to relocate after disasters, and healthcare is going to be more of an issue for them as compared to people who are middle and upper class, who might have enough money to weather these events. It's going to be disproportionately hard for low-income communities and minority communities to deal with the effects of climate change. I haven't really talked about biodiversity, but obviously this all is going to affect biodiversity, and plants and wildlife are not going to be spared. Humans are not going to be spared. This climate change is not just going to have those direct effects that we've already talked about, but it's also going to change the phenology, the cyclical and seasonal patterns that plants and wildlife partake in. So their development and their growth and their behaviors of plants and wildlife, they depend on cues from climate. And as these cues from climate start to shift around, different plants and animals that might depend on each other, they're not going to be able to interact in the same way as they used to. So they're getting out of sync. And in the cases that plants and wildlife can't handle the changes, They either are just going to have to change, they're going to have to adapt, they're going to have to move, or they're going to have to die out. And that brings us to this point. We are currently probably in the sixth mass extinction that the world has ever seen. There have been 5 instances over the course of about 500 million years of the history of complex life on Earth, where around 75% of all species went extinct. And we are currently seeing levels of extinction that mirror those mass extinction events. 100 to 1,000 times more animals are going extinct currently than they were before modern history. And 1/3 of all species are thought to be facing extinction by 2070. That's partly because of our impacts on the climate and our impacts on the environment in general. This has led to what's been termed the Anthropocene, a new geological time period that is defined by humans being one of the dominant influences on the environment. Okay, so now we'll talk about ecological restoration and climate change. Unfortunately, people tend to ignore this tool that can be used to help fight climate change. And we're also going to talk about how we can help natural communities and also human communities around Chicago withstand climate change using ecological restoration as a tool. So the first tool in our arsenal for as restorationists, the first thing that we really have to consider, carbon sequestration in soils. So living plants, they take in CO2 from the atmosphere and they photosynthesize and they have metabolisms and they use all this fun chemical machinery in their bodies to create leaves and wood and biomass. So this dead material that it then contains carbon that was once carbon dioxide. And when the plant materials rot away, they either return to carbon dioxide or they become methane, which is another greenhouse gas that forms under anaerobic conditions. So when there's not enough oxygen, carbon in plant materials becomes methane. But most of the time, there's enough oxygen that it turns back into CO2. For trees, most of the carbon and most of the CO2 that was taken up is stored above ground. In grasses and wildflowers, a larger portion of their biomass is stored in their roots. And here's an example of that. This is a natural grass that grows in grasslands compared to an agricultural grass, and they're showing the extent of the roots in the soil. Lots of roots in the soil of a grassland grass as compared to, the roots from an agricultural grass, probably wheat or something along those lines. And when, as I've mentioned, when organic material is left in the air, it turns back into CO2. But when it's buried in the soil, it's much slower to decompose because it's less exposed to oxygen. And most decomposing organisms, so bacteria, fungi, insects, they generally need oxygen in the environment to help them break down any materials. And as I've mentioned, anaerobic decomposers, they don't require oxygen, but they work much more slowly. So when plant material is buried, it is less likely to decay. And when it's buried in cool and wet conditions, even slower to decay. This picture is of a peatland, or you might colloquially call it a bog, and it's wet and it's kind of cold, and there's a bunch of plants growing in it, and as those plants die, they accumulate in the water and they don't decompose very quickly because of the cold, acidic, wet conditions. So wetlands that store huge amounts of carbon. Okay, so we know where carbon can be stored, how it can be stored, and why it's stored. But let's talk about degraded and intact ecosystems. So human disturbance generally causes soil carbon to be released, and it also leads to a loss of species. That's because tilling, and just moving the soil around, it injects air and oxygen into the soil. And many species that live in our natural areas, they can't deal with the human alteration, so they start to die out. So some of the plants that would store carbon in the soils, they just start to disappear. And the carbon that was in the soil, it starts to disappear when humans disturb the environment and create these degraded habitats, such as what you see on the right here. This is a buckthorn thicket, pretty much all just buckthorn in there, almost nothing growing underneath it. And there would have probably been grasses and wildflowers underneath that buckthorn that would have been storing carbon deeper into the soil, but now that's gone. Whereas buckthorn, which is something that is non-native and weedy, an invasive species, it has pretty shallow roots. And a lot of the species that human disturbance benefits, they tend to have shallow roots and they will store less carbon in the soil. And they can even create conditions where decomposition is accelerated. So buckthorn leaves and some of these other invasive invasive species that have leaves that get into the litter in our forests and forest preserves, they actually cause the litter to decompose more quickly, so it can't get stored in the soil. Basically, intact ecosystems, they don't have as many of these problems. They're more biodiverse. They store larger amounts of carbon. And what does that tell us? That tells us that we can use plants to remove CO2 from the atmosphere and store that carbon in the soils and in plant biomass, especially in these degraded areas where our practices have already removed the carbon from those soils. We can actively put that carbon back into the soil through restoration. And what is ecological restoration? It's where we reintroduce species and processes that allow ecosystems to function properly. And that includes storage of carbon. We try to decrease or reverse as many of the impacts of human disturbance as we can, but this requires input of time and resources. It was pretty easy for us to cause these issues with the environment, not just through climate change, but a lot of times we actively cause these problems in the first place. And we can't just sit back and, expect nature to sort itself out when we've already been influencing the environment. But we've pretty much always been influencing the environment throughout human history, even as far back as, prehistory. Native Americans and other indigenous peoples around the world, they were managing the land in ways that were compatible with biodiversity. So they weren't necessarily killing anything off, but they were affecting the environment just as we are now. If we want to fix these problems, we actually have to start investing time and resources into it. Here are some examples of habitat restoration. This area over here is in Northwest Cook County at Bluff Spring Fen. All these wildflowers are there in large part because of restoration efforts. So if not for humans trying to keep out the invasive species like buckthorn, this might have been covered up in trees and shrubs. Here's another example, a before and after shot. On the left, we have in 2011, an area that was totally covered in buckthorn and shrubs, not very diverse. You remove all that, and now you have probably dozens, if not hundreds of species of plants, definitely hundreds of species of insects, fungi in the soil. All these different organisms, they rely on plants. So even though a lot of restoration work focuses on plants, if we can return the diversity of plants that was once there, we usually see that the diversity of insects and wildlife and everything else will follow at some point. This is just 2 years after removing the buckthorn and other invasive shrubs. Another great example, a dense buckthorn thicket on the left and a diverse open area with wildflowers just 2 years later. So while I've been talking a lot about the ability of natural areas to store carbon, it's actually there's not a lot of potential there overall. There's a lot more potential for us to save areas before they get degraded, But unfortunately, that's not a very viable option in Chicago. We've basically used up all the land that we can, and we've degraded just about all the natural areas that we have left. So even though we're not necessarily going to store huge amounts of carbon in the Chicago region or in Cook County, we're not going to solve global warming and global climate change in the whole world just by doing restoration work in Cook County. Now, if everybody across every area across the world started doing similar things, that would have a huge impact. But overall, it's probably better to just save the land that isn't already degraded. But still, ecological restoration can help with all those different side effects of climate change. And ecological restoration in forest preserves can help us become more resilient to the impacts of climate change. We'll have an easier time handling all these changes that are coming down the pipeline if we start worrying about the health of our natural areas. And that's because healthy natural areas, they perform what are called ecosystem services. They do things that don't just benefit plants and wildlife, but that also benefit humans. So we'll talk about some of those ecosystem services and benefits now. Restoration and flooding. So here's a cool example. Chicago has always been a very wet place. We built so much of our settlements on what was once swamp or wetland area or seasonally wet areas with a high water table. So areas where you don't have to go very far down to actually reach water. This is at LaBagh Woods. This is a flat woods area. You can see this at the bottom left corner, this sort of pond open area with grassy sedge plants around it. And this is a great example of how natural areas will store water. This area completely dries out in the summer. But in the spring and early summer, it has water. And a healthy natural area will actually be able to store more water, more of our floodwaters. Natural areas that have a nice ground cover of grasses and wildflowers and high diversity of things, they are able to stabilize the soil better. So you have more ground cover and more roots to actually lock the soil in place. So when it does flood, you're not going to see all the sediment washing into the streams. All the plants here and the microbes in the soil here, they're very effective at helping to filter out pollutants in floodwaters, so it helps with water quality. And these denser, deeper roots also help alleviate soil compaction. So when we degrade a natural area, soil can become hard and it can become difficult for water to pass through it. But roots actually will tunnel down into the soil and eliminate some of that compaction and actually act as channels for water to enter the deeper layers of the soil. Organic matter in the soil also has a high capacity to store water, and plants also absorb water directly from the soil and then emit it back into the atmosphere through evaporation and transpiration. So all these different things that plants are doing to help alleviate the effects of flooding or prevent the effects in the first place. It's huge benefits that we have when we restore these wetland areas or these seasonally wet areas, which much of Chicago would have been. Restoration also helps with beneficial wildlife. I mentioned pollinators already. Pollinators are being impacted by loss of habitat, which we can directly fight by restoring habitat for them in the forest preserves, and also by climate change. So by giving them more habitat, they're less likely to be impacted by climate change. And that'll help with food supplies, because so many of our food and agricultural products rely on pollinators, and just our general landscape. So all those flowers that we have in our gardens, a lot of them rely on pollinators as well. So if we want to see those proliferate, then we want to have more habitat for pollinators. Insectivores, they also are benefited by restoration, and things like creatures like bats and opossums, they eat insects and other things that carry disease. So I forget what the exact numbers are, but possums are touted as being very effective scavengers of ticks, and bats eat huge amounts of mosquitoes. So when we create habitat for them, we're helping to decrease these effects of climate change, mainly disease and spread by insects and ticks. Predators as well. So when we create habitat for small predators like coyotes, they also will eat some of the creatures that can help spread disease, specifically rats and other rodents. There are a whole bunch of other impacts of climate change that restoration can help address, specifically woody debris and wildfire hazards. This is a huge problem in Cook County, where we've had an insect from Asia called the emerald ash borer that killed off large numbers of really big ash trees. These trees are now all dead and laying around in the forest preserves and becoming a hazard for wildfire. But restoration practices, we generally remove a lot of that woody debris, and it becomes less of a fire hazard. Restored areas also help to recharge groundwater and filter out pollutants. So that helps to address water scarcity, drinking water scarcity that might arise in the future. Okay, so after all that, I really just want to leave you with a few takeaways. Climate change is real, and it is probably the most critical challenge that we have ever faced. But ecological restoration can be used to help sequester carbon and can also help to mitigate the impacts of climate change, not only for humans, but also for plants and wildlife. And you can be involved in that process. You can help with ecological restoration in the forest preserves right now. You can volunteer and help fight climate change in your community and abroad for people, plants, and wildlife. So that's the end of my presentation. Here's my contact info. I will leave that up for a few minutes or a few seconds, and we will move on to the next part of our presentation, the panel discussion.
Thank you, Derek, for all of that. That's a ton of really helpful information. Before we get to our panel, I just want to remind everybody, if you have any questions for Derek or questions for any of our panelists, type those questions into the chat box or use the Q&A function in Zoom, and we can see about getting you an answer to any of those questions. All right, so next we're going to have our panel. I'm going to introduce the folks who are going to be talking about some of the really tangible things that you can do with regards to climate change at the forest preserves of Cook County. So first we have Rebecca Collings, who is the Senior Resource Ecologist for the Forest Preserve District of Cook County. She and her team monitor the flora and fauna of the preserves and use the information to develop management plans. Design ecological restoration projects and priorities, and to measure success towards the Forest Preserves of Cook County's goals of restoring 30,000 acres to high quality ecological health. Next, we have Laura Dean. Laura is a volunteer with the Beaubien Woods and the Whistler Woods. She's an urban planner by trade. Laura Dean is a stewardship volunteer in the Calumet area, as well as training in the U of I Extension Masters Naturalist Program. Thank you for joining us, Lauren. And finally, we have Arthur Wawrzyczek, who has been volunteering at LaBagh Woods in Chicago for more than 2 years. He also teaches AP Environmental Science at Lane Tech High School and runs the Mr. W Science website and YouTube channel that makes video content for environmental science students and teachers. So thank you for all of our panelists who are here. I'm going to pass it off to Derek, who's going to be facilitating facilitating the panel. So Derek, welcome back.
Okay. Yes, so I think we'll start off easy, and we'll start off with some questions for our two volunteers. Art, Lauren, how did you start volunteering?
Yeah, I started getting interested in ecology actually through honeybees, which are not actually great for the environment, but that is like a whole other can of worms. But I am a beekeeper as just a hobby, and I got really interested in starting to learn all of the other kind of plants and animals that live around my house, because I was seeing my bees bring pollen that was different colors at different times of the year. And I was curious what kinds of plants they were visiting. So I started learning kind of the blooming schedules and the pollen colors that correlated to different trees and plants that we know that honeybees like to visit. Um, so I started learning how to identify trees, how to identify all these plants in my neighborhood, and that kind of just ballooned into birding and restoration work and all kinds of other ways of getting involved, getting outdoors, particularly in the winter. And that's how I found the forest preserves.
Hi, I'm Art. So I actually started volunteering because a friend of mine from college brought me to LaBagh to start volunteering. We both finished our studies at DePaul University, where I have my environmental science background. And at DePaul, there was a huge focus on restoration ecology and urban ecology as part of the curriculum. But ironically, I never actually got to practice a lot of the theory we learned. It was kind of like, oh, here are the scientists in their ivory tower analyzing data, but they never get their hands dirty. And that was kind of true. I never had the opportunity to actually do the restoration work that I was studying. I even wrote my capstone on oak savanna restoration. And like in hindsight, I'm like, wow, there's so much more I could have learned, but I never did. So when I started volunteering, like everything just clicked, and it was this sort of sense of purpose from being able to apply something that in your brain was always theoretical, suddenly has become practical and applicable. And I just felt really good about it. So now I'm here.
Cool. That's a good segue into a little bit meatier of a question. Why do you volunteer? What are the reasons?
I know for me, I am someone who has had to figure out ways to kind of manage my own kind of anxiety around climate change and kind of what we have in store for us in the future. And given my background is in community development as a planner, so I was already very much bought into the kind of localized, specific neighborhood scale changes that once you work collectively and you see those things spread, cause big impacts. And I also, as kind of the other side of that, I'm a big believer in kind of the role of doing the hands-on work to kind of change our narratives around how these things work. I am someone who I know a lot of people who are very politically engaged and are very kind of in touch with what's going on, but when it comes to climate and specifically people's us as humans and our reaction to climate, I tend to hear people getting bogged down in this kind of statistic of how we know that 100 companies are responsible for 70% of climate change emissions. And so how are we possibly going to create change on these small neighborhood levels if that's kind of what we're up against. But again, me coming from a policy background, I really see those work days as more of a form of kind of interpreting our relationships between those environments, building connections and getting people to feel invested in those spaces, and hopefully that will also kind of contribute to kind of this larger collective appreciation that we are going to have to need for those ecosystems if we're going to get the big policy wins that people kind of say are out of their reach.
Right. A lot of what goes on in restoration work is community building and building advocates for the environment and the forest preserves. I totally get that. I've been a longtime volunteer myself. I started off at LaBagh Woods as well, a little bit before Art. How about you, Art? Why do you volunteer?
Well, I mean, so I don't want to be the hypocrite who talks the talk but doesn't walk the walk. So that's one thing for a bit of just pure hedonism there. I'm a strongman competitor, and we don't get a lot of cardio in our training, so it's fun to just go out there and move around and walk around a lot. That's literally part of my workout regimen. But on the more practical side, when I first started volunteering, everybody there was so welcoming and just warm and friendly that it sort of became this like community event, like Lauren was saying earlier, and how you reiterated. I love this feeling of just being with a group of people who are just working for the same goal, and just being part of that community is wonderful. And just being able to see consistent progress. Like, I've only been volunteering for 2 years, and within those 2 years, I see areas that we worked on. We cut down that buckthorn. We put seeds into that seed bank. That was our work, and it's so fulfilling to see that what you're doing, it's so rewarding, is actually having an effect so quickly.
Yeah, it's amazing. Even after one work day, I mean, just seeing, if you're doing brush cutting, for instance, you might see an area that was buckthorn thicket, and now it's wide open, and now it kind of looks a little bit like a moonscape, like a disaster struck. But a year or two later, huge differences. So okay, let's switch gears a little bit. Let's talk to you, Becky. Can you tell us a little bit about your career and how you got into the environment?
Sure. I'm also a native of Chicago, and from the northwest side of the city. I was always very interested in science, and particularly biology. So I was this close to going into a career in medicine, but I really enjoyed as our volunteers have mentioned, the hands-on component of ecology, and getting to make that connection between what you're seeing on the ground and the science component. I will say my first experience with restoration was when I was about 10. I went to a very early North Branch seed collection work day at Bunker Hill. So that was kind of, maybe my first experience into restoration. I didn't know that was obviously a career at that time. It took me a long, winding road to get there, but I would say just having early exposure to nature as a child, and then being interested in science. Once I kind of heard about ecology and natural resources as a career path, it seemed like a natural fit.
Thank you.
You're on mute, Derek.
I muted myself again. Sorry. We'll go back to you, Becky. And I guess we'll kind of open this question up to our volunteers as well. But can you share any stories of how specific restoration projects might have helped to mitigate the impacts of climate change for a specific community, or make that community more resilient to future impacts? I mean, in theory, this is all, good, and we know how it's supposed to work, but are we actually seeing this happening anywhere around the forest preserves? And maybe our volunteers have seen similar impacts around the communities the forest preserves that they work at.
Derek, do you mean natural communities or human communities, or either?
Both, I guess. We can talk about both.
Okay. Well, one example I was going to share is a restoration project that I've been a part of in the Calumet region on the southeast side of Chicago at Eggers Grove. This preserve, we've done a wetland restoration project, and it's really been about 10 years in the making. And as part of that process, we were able to remove invasive species from the wetland. These are species like Phragmites and purple loosestrife that had really formed a monoculture within the wetland and prevented high quality habitat for nesting wetland birds. So we were able to remove the invasive species, and then we were also able to install a water control structure. So as Derek's presentation mentioned, changes in hydrology, these already were present on our landscape due to urbanization, and we're going to, and have already impacted our wetlands. So having the ability of this water control structure, with this water control structure, to be able to manipulate water levels, this is helpful for us to both mitigate past impacts of changes in hydrology on the site, and also prepare for what we know will be future more intense storms. And so we've had the ability now for the last few years to draw down water levels in the marsh and install some wetland plants, some native wetland vegetation. So this is not only improving the biodiversity of the site, we're also able to kind of control when water is coming in and out of the system, so that we can store water on site, when it's raining, and then we could release water when it's not raining. So I see that project as really like a win-win for both for the health of the wetland and also for how water is moving through the site.
Lauren or Art, anything to add?
Just a plug that there is a workday scheduled at Eggers this Saturday morning. If anyone is interested in checking it out, I will be there with the Illinois Extension contingency, who will also be on site on Saturday. So it's a very cool site.
Nice.
Great. Yeah, I'll talk a little bit more at the end about how people can specifically get involved, find a workday near them. And obviously you can contact me with any questions about how to volunteer, anybody out in the audience. With that being said, let's shift gears a little bit again. So Art, how has volunteering at LaBagh Woods impacted your career as an educator?
Oh, that is a very loaded question. Well, immensely, and in ways that I would struggle to fit in however much time we have left. I'm very lucky in that I get to teach environmental science. It's a relatively specialized niche field, and not many high schools have as big or developed as an environmental science program as Lane Tech does. But anything that builds my repertoire of environmental issues translates quite directly into my effectiveness as a teacher. And I was trying to find one really good example. And this year, I have a student. So some background, I teach a group of students at Lane Tech who have opted in to be in a specialized STEM program, which means they take the highest level science classes we have. We oversample their curriculum with math and science courses, and it requires them to compete in science fair every single year. And this student is doing their research project on macroinvertebrate diversity and restoration. So how macroinvertebrate, so bugs and stuff, how the diversity in those communities differ between degraded, remnant, and restored oak woodlands, which is luckily what more or less what we have at LaBagh. Remnant is, let's use that term loosely, but close enough. There are some pretty old oak trees there. And I would not be able to mentor students in that capacity or give them the amount of information that they could use if I didn't have this restoration and volunteer background. It has introduced me to people that I can use as resources, that I can really use to help students work through their goals as young budding scientists themselves.
Wow, that's awesome. I mean, it's kind of a spin on the idea of networking, but for good and for your students.
If I could interject, we have an audience question that Art could answer. If you have any suggestions, now we know you teach high school, but if you have any suggestions on how to teach climate change to elementary students or maybe just younger students, and we can get you in touch with Jeremy maybe after the webinar to provide some resources for that person specifically, but just, you know, any resources or any tips on how to teach young people age appropriate issues with climate change.
So Jeremy and I know each other very well. We've already worked together on a project in the past. I wish I had a better answer, and I can probably prepare one in the future, but the pedagogy between elementary and high school is, I mean, it's a fjord apart in how it works. So I don't have a direct answer off the top of my head, but I know that Jeremy will definitely get in touch with me, and I can help him work through that.
Thank you. That in and of itself is interesting, that it's such a different world between elementary and high school.
Great. Okay, I'm going to try to get through, I think, 2 more of our prepared questions before we move on to audience questions. This question will be for Lauren, and then we'll go to one more for Becky. Lauren, as somebody who's been trained as an urban planner, what have you noticed about the role of natural areas like the forest preserves in terms of health of urban communities?
Yes, this is the thing that I really think about the most when I'm out in the preserves. Derek discussed a little bit, and by a little bit, I mean quite a bit, about kind of the more direct impacts that climate change is and will have on our communities. But climate change and the things that go along with it also have a big impact on the types of policies that planners do and have been relying on for a very long time in more indirect ways. My background in particular is in community development, specifically housing. And one of the big things that I think about a lot, particularly with the restoration project that Becky just shared about, rainwater and flooding. While that's obviously an issue for folks who are directly in the line of a flood, something else that we see a lot in Chicago are people's basements flood a lot when the storm sewers get overwhelmed. And that flooding has an impact on how people can continue to afford to invest in their homes and their repairs in their homes. We see similar things with energy costs. We know that things like tree canopies and natural areas reduce what is called the urban heat island effect, where if you live in a neighborhood with less tree coverage than a neighborhood that maybe has significant tree coverage, that neighborhood is going to be warmer in the summer and colder in the winter than a comparable neighborhood in another part of town. Both of these are really important factors when we think about long-term housing tenure and housing stability, particularly in communities of color. We know that access to mortgages, access to home ownership has largely been dictated by the people that banks and insurance companies historically have decided to lend to or not to lend to. And we continue to see that gap today, where white families are significantly more likely to pass wealth along between generations because they've had that head start. And when we start to think about things like the cost of creating more energy efficiency in your home, the cost of air conditioning, the cost of heating, the cost of doing repairs when your basements flood every year. Even if you're someone who already has a mortgage or already owns your home, those are large costs that add up and undermine that kind of long-term security and that long-term wealth building. And again, that's particularly important in communities of color, because they haven't had access to those things for the same amount of time as white families. The other thing that we talked about a bit with pollution and carbon sequestration, those have big impacts on air quality and public health, which again, with my lens as kind of a housing policy person, has impacts on housing values, but it also has long-term effects on people who are growing up in those environments. And this is another place where, again, we see those disparities hitting communities of color much, much harder than those neighborhoods that are predominantly white. We've seen this in the last couple of years with the move from General Iron, trying to move from Lincoln Park down to the southeast side around Calumet, where there's already a disproportionate amount of the air pollution that occurs within the city is already in that neighborhood. We've seen that with the Hilco demolition in Little Village last year, where we all saw those photos where Hilco decided to demolish a plant without proper permitting and just blanketed the entire neighborhood in smog for days. These are all kind of those cumulative, small but cumulative and long-term things that can be mitigated and we can offset by making sure that our natural areas are accessible, not only kind of on the North Branch or on the lakefront, but also making sure that we're maintaining these types of spaces across the city and that everyone has equal access to those types of spaces. The other thing that I think about a lot from a policy side of things is just the kind of inability to separate ourselves as humans from these natural communities. We are a part of those ecosystems, whether we like to think of ourselves as part of it or not. And when we can incorporate more kind of planning and more policy decisions that look at overall health of communities that are both human and non-human, those things are going to provide a lot of benefits for people as well. So.
Wow, thank you, Lauren. That was a great answer. I hope that urban planners are thinking just like you are in the future, although it's kind of hard to plan around something that's already been built for about 200 years. So let's hope that cities of the future are take heed, your word. We'll go into one last really kind of heady question for Becky. So let me just look for this question exactly. Don't want to make a mistake. Okay, so Becky, how does prescribed burning, which releases CO2 into the atmosphere, help to restore Chicago's ecosystem and fight climate change?
Yeah, that's a great question. As you mentioned, we do prescribe fires in the forest preserves of Cook County. Our fire season can vary, but on average, I'm going to say we're burning approximately 10,000 acres a year. Sometimes more. So one thing that we think about with prescribed fire, as Derek mentioned in his introduction, there's carbon that's stored in our forest preserves, both in the above ground biomass and the below ground in the soil. So when we do a prescribed fire, if we're in a prairie, we are burning a lot of that above ground biomass, the grasses and the flowers that are above the soil. But of course, what's below ground, it remains intact. So there is research that shows with a grassland, like a prairie, when you do a prescribed fire, you're burning off the carbon that was sequestered from that year's growth. So whatever those plants took out of the atmosphere that year while they were growing is being re-released into the atmosphere during that prescribed burn. But then the next year, the prairie is going to grow back again, and oftentimes with more vigorous growth than the year before, because it's been burned, and that helps to provide nutrients for next year's plant growth. So really the above ground portion of the prairie is just being cycled through this, the carbon that's in that and those plants is being released and then sequestered again the following growing season. But then you do have the net benefit of some of that carbon is being stored, as you mentioned, through the roots and the sloughing off of those roots in longer term storage pools of soil organic matter. There's some research that looked at forests in the East Coast that have been prescribed burn. Now forested systems are a little different, because when we do a prescribed fire in a woodland or a savanna, you know, by and large, we're not burning trees, we're really burning leaves and ground layer vegetation. So that has a similar effect of stimulating more growth the following year. And as I mentioned, there's some research from New Jersey that the Forest Service did, and they found that there was within 2 to 3 years, that amount of carbon was then recaptured by those plants. And again, a portion of that will be over time incorporated into those longer term soil storage to soil carbon, which is a longer term storage pool. So it is, I would say, neutral to beneficial to prescribe, you know, in terms of carbon by doing a prescribed fire.
Right, but we get all the other benefits of the added biodiversity and complexity of the habitat, that even if it's not necessarily, you know, storing a huge amount of carbon, it's helping us become more resilient.
Absolutely. And I'll mention there's a lot of research that's really looked at, you know, the impacts of doing prescribed fire in the Western US, where fires are typically more intense and all consuming, where, you know, a lot of the above ground biomass, including trees, is consumed in a fire. And in those studies, they found that prescribed fire is really a net plus, because by doing regular prescribed fire, you're removing some of those finer fuels in the ground layer that will prevent often the catastrophic scale fires that are burning trees and releasing much more carbon.
Thanks for that, Becky. We are running out of time. I wondered how many questions do we have time for, Alana?
Well, we probably only have time for 1 or 2. We have quite a few, so I'm going to apologize ahead of time. We're not going to get to everyone's questions. Please feel free to email us personally, and we can send you an answer to your questions. So I will just ask, I'll start with, how has the ecological restoration efforts of Friends, what has it done to decrease the amount of invasive species in our forest preserves? So I'll throw that out maybe to Derek or Lauren or Art, if you want to talk about how the ecological restoration efforts have decreased the amount of invasive species in our forest preserves.
Well, Art, Lauren, you're as qualified as anybody to talk about it, I guess.
So I know that the sites where I work, there is the actual pulling of individual species that we do a lot of targeted work. I work primarily these days on the southeast side around Calumet, where things are a little bit less established. I know the North Branch, there have been the same crew go out there every weekend for decades and decades now. And so that's a really cool example of how those things build over time. But the thing that I get excited about is less the kind of manual removal and more the kind of year over year change you're seeing where by targeting a couple handful of species, we're really focusing on creating spaces and opportunities for the native species that we'd like to see kind of reemerge. So I guess from my perspective, I'm thinking about it less from the perspective of diminishing the number of invasive species and more creating new opportunities for native species to reemerge and kind of recompete and get their roots down, both literally and figuratively.
Question that had come up is that wondering if there's any information about the correlation over time between population growth and the average temperature on the planet. Someone wants to field that.
Yeah. So that it's an odd question to answer because one, estimating the size of a human population before written record is extremely difficult to do. So it'd be hard to get a really good idea of human population sizes when we're talking about, you know, some of the early migrations out of Africa and through Europe. There are estimates, but the range is a little high on those. It's also really difficult to really test it because the thing that actually affects the global temperature, which are the carbon emissions, we didn't really see a massive boom in that until the 1800s, right around the Industrial Revolution. There was some burning for fire and some stuff like that much earlier, obviously. But most of that was carbon neutral. It wasn't until we started using long-term carbon storage sources that we started to really disrupt and introduce an excess amount of carbon compounds into the atmosphere. So a better metric is greenhouse gas concentrations, not so much the size of a human population. And you can make the argument that as the population increases, the per capita CO2 emissions also increases, and that's true, but that might not be true moving forward in the future. So it's a great question, but I don't think there's a great answer for it.
I would also say, though, from the policy side of things and thinking through kind of making sure that we're able to meet everyone's needs, if we're thinking about population growth since the Industrial Revolution, that goes hand in hand with technology advancement, which means that hypothetically, we should be able to provide what we need for everyone while actually having less impact. The kind of mismatch occurs when we're focused on creating more than what we actually need, because of whether that is maybe farm subsidies, whether that is subsidies to a particular industry, because we needed it at one point in history and now maybe it's not as relevant, but it's been so baked into the system that it's hard to get rid of at this point. I think it's less a question of too many people and more a question of how are we allocating our resources and how is technology allowing us or not allowing us to provide for what everyone needs.
Okay, well, this has been a very stimulating conversation. I think we might have to cut it there. We're already a minute over, and we still need about a minute or so of your time for all of you who have decided to stick with us through to the end of this. Thank you very much, as well as thank you to all of our panelists and Pascal for doing the intros. I think it's been a fascinating discussion. And I really hope that something that we said here today might have taught you something if you were already a volunteer, or if you aren't already a volunteer, maybe this will inspire you to, get up and do something in your own community that, will take your mind off of your climate anxieties and help plants and wildlife and communities all around Chicago. For those of you who might be interested in learning how to find a volunteer workday. It's pretty simple. I am going to quickly share my screen again. FPCC.com/volunteer, pdcc.com/volunteer. You can go there and you can find all sorts of interesting documents. You can to sign up for a workday, you are going to have to log in or create a account with the forest preserves, and they do have a way to find volunteer opportunities near you. So here on this page, find a volunteer opportunity, browse a list of opportunities. You can search the online volunteer system. That's what I would suggest. And from there, you get this nifty map of different regions in the county, find your region, and go from there. So if you wanted to find everything going on in Central Cook County, here you've got a list. Bemis Woods South, Bobman Woods. There are a few dozen. I'm not, Becky would be the one to know this answer, how many different sites have volunteer work days, but there are dozens across the county. You can find them all by going here.
There's 92 stewardship sites.
92 stewardship sites. Okay, and of course you can contact me. My email is pretty simple, derek@fotfp.org. I'll put it in the chat again. You'll probably see that name pop up in the future. Feel free to email me with any questions regarding volunteering or the forest preserves in general. And again, thank you everybody for joining us, especially our panelists. Unfortunately, panelists, you're not going to be able to hear everybody's applause, but I'm sure they're applauding. So I am going to end our meeting now. Thanks.